Physics Part 388. We have met this type of curve before in talking about the decay of current in a circuit containing a capacitor and a resistor. When you apply the DICE experiment to model radioactive decay, the 6000 emissions, all dice covering 6 are removed because a nucleus has undergone radioactive decay. It is no longer available for further decay. Thus, we can describe how rapidly a sample of radioactive material will decay. A graph of the number of undecayed nuclei in a sample against time has the typical decay curve shape shown in the figure. It is not possible to state how long the entire sample will take to decay its life. However, after 3 minutes, the number of undecayed nuclei in the sample has halved. After a further 3 minutes, the number of the undecayed atoms has halved again. We describe this situation by saying that this radioactive nuclide has half-life T into half of 3 minutes. Radioactive decay curve. The half-life of a radioactive nuclide is the time taken for the number of undecayed nuclei to be reduced to half its original number. The half-lives of different nuclide have a very wide range of values. Examples of some radioactive nuclide and their half-lives are given in the table. The radioactive nuclide and their half-lives. Let's talk about uranium-238. Its half-life is 4.5 into 10 power raised to 9 years. Radium-226, half-life 1.6 into 10 power raised to 3 years. Radon-222, the half-life is 3.8 days. Francium-221, the half-life is 4.8 minutes. Astatine-217, the half-life is 0.03 seconds. We shall see later that half-life may also be expressed in terms of the activity of the material. Note that half-life is similar to the time constant which we met in our previous chapters. Both half-life and the time constant relate to the time taken for a certain fraction of the quantity concerned to decay. For the half-life, that the fraction is 1 over 2, for the time is constant, the fraction is 1 over e, or about 1 over 2.7. If you measure the cut rate from a nuclide with a very long half-life, you might expect to obtain a constant value. In fact, reading of the rate meter fluctuates about an average value. This demonstrates the random nature of the radioactive decay. We've got an example for you. The half-life of francium-221 is 4.8 minutes. Calculate the fraction of the sample of francium-221 remaining undecayed after a time of 13.4 minutes. The half-life of francium-221 is 4.8 minutes, so after 4.8 minutes, half of the sample will remain undecayed. After two half-lives, 9.6 minutes, 0.5 into 0.5 is equal to 0.25 of the sample will remain undecayed. After three half-lives, 13.4 minutes, 0.5 into 0.25 is equal to 0.125 will remain undecayed. So the fraction remaining undecayed is 0.125 or 1 over 8. Now it's your turn. Using the half-life values given in the table, calculate the fraction of a sample uranium-238 remaining undecayed after 9.0 into 10 power raised to 9 days. I beg your pardon. I would rather like to do it in the next video because I don't want to confuse my listeners, the viewers, with the values that I provide over here. So I'll take your turn in my next video, having had gone all through the details I prefer to keep it in the next video.